welcome back to my channel. Kudos for making it this far. Today we're going to be talking about inheritance and how we can use inheritance for our classes in Python. So inheritance is more like classes inheriting from other classes, where you have one class as the parent class, then you have a child class that inherits from the parent class. So the concept of inheritance is just that you can use a class to get all the attributes, all the methods, the properties from the parent class and use it on your child class. So your child class consumes the whole attributes from the parent class and has its own attributes that it can use to perform some certain operations in Python. So I want to show you guys how we can go about using inheritance in Python on our classes. I'm going to create a parent class. Then from that parent class, I'm going to create a child class to consume that parent class. So that child class becomes the derived class from the parent class. Okay, I'm going to use a class of person like we used in the last example. I'm going to create a class called person. Then let me just drop it here. So now I've created a class called person, and I want this class to be the parent class for my child class students to inherit from. So I want a class of person, and for my child class it's going to be a student. So a student can be a person. So you understand how the concept works, the flow works. So for a student, he can be a person and have the attributes of a person, which is the first name and the last name. So here I simply created a class named person, and I pass the init function like we talked about in the last class, so that whenever anybody consumes this class, it gets the available first name and last name automatically to that object. So I also have a def function here that prints out the first name and the last name. So now this is my basic parent class. The next thing I'm going to do now is to create a child class that inherits from this parent class. Okay, so it's very easy to go about creating a child class. The simple thing you need to just put in your mind before moving on is that to create a child class, you just simply have to pass in the parent class into the child class when you are declaring it from the first onset. So it goes like this. I will just call my child class. I call this class student. Okay, so I say students, and I use the brackets notation to pass in the parent class I want to pass. So I have a students called I have a class called students, and now I am passing in the person as the parent class. So for now, I don't want to do anything much. I'm just going to use the pass key like we have been talking about here. The pass key allows me to just create a class and not pass in any attribute or properties, as the case may be now. So now when I come to my console, let me show you how it works. I'm going to create an object from this student class, and I'll call it X. For clarity, the X is equals to student. Then I'm passing the first name and the last name. I'll call him John. Then I'm going to pass in a last name. I call it Doe. So when I run print this to the console, I should be getting, let's call x dot print first name. Let's call that method we defined in the parent class. Let's call print name and see what shows up on the console. Okay, so now when I run this, I should be seeing, clear this up a little bit. So now in my console here, I'm seeing John Doe as my result in the terminal. That's because now I've been able to create a class called students that inherits all attributes, all properties and methods from the parent class person here. So now this class has all the attributes of the person class, and as such becomes a child of the parent class. What we just did here was that we used the student and the bracket notation to pass in the parent class. So now this gives us all properties, all attributes, and all other functions that is available in this class to the student. So I can always call it on the student class without having any problem, like I did on line 12 here. I just simply said my object X is equals to student, and I passed in the name and the surname. But this is just the surface level. We need to do more with this. I want to be able to pass in other attributes and methods to my student class and not have to declare it in the parent class. I want to proceed from there so I can show you how we can do other stuff on our child class, and it's just going to be only available to the student class because it's a child of the parent class. The parent class is not a child of the student class. Okay, so understand that concept. Once this child inherits from the parent, all attributes and properties are available to the child. But when the student class gets its own attribute and functions, it is not returned back to the parent, because the child is the one inheriting from the parent, just like the biological sense that the child inherits certain features from the parent, so the parent cannot inherit features from the child. Okay, so it's all about that concept. Now I want to add in an init function to my students class, but I have a challenge. If I pass in an init function to this students class, all these attributes I have inherited from this um parent class is not going to be available to me in my child class anymore, because when you assign a new init function in your child class, it eradicates all the initial init function from your parent class. So how do we solve this issue? We can solve this by simply using the parent class again on the child class, or we can use the super function in Python. So let me show you guys how we do that. If I want to use more functions and attributes in this class without having to eradicate the main ones coming from the parents, I'll first of all define the init function here. I'll say init, then I'm saying self. We already talked about this. This is the instance of the class. Then I'm using the first name again, the first name and the last name. Then I'm going to call on the person. Now, by doing this, for me to be able to still inherit the parent class, I will just call on the parent class here again, person dot init. Okay, dot init. Then I pass in the same attributes I used from the last time. The self, the f name, and the last name. What I've been able to do is that I have defined an init function in my child class, and I still want to possess the same init functions from the parent class, so I passed it back again into my init function here. This is one way you can go about it. Another way you can go about it is to use the super function. If I'm using the super function on this, I will just simply remove the person class here and use the super. Then I would remove the self instance, and my code should still work as expected. So I'm going to show you this and the other version, and you would see how they both produce no error, showing you that we have been successfully allowed to, showing you that we have been able to inherit the features of the parent class still without any errors. So I'm running this to the console. I should have no error in my console. I still have my John Doe there. And when I go back to the initial declaration I did here, passing the parent class itself, I should still have no error, John Doe. So this allows me to still use the parent class and proceed with other attributes of my child class. So now I want to add a year to my child class so that the students can also have a graduation year. I'm going to call it grad year or graduation year as the case may be, so that the students can always refer to that. So I'm going to call it in my child class here year. I'm going to say self the graduation or year. I want to use the super here. The super is more easy to use because it automatically locates the parent class for that child class. Then I'm going to use dot self dot what should we use? Graduation year is equals to year. Okay. Now I want to pass in a year to this student so that he gets the year of graduation as well. So I can just come here and say he is a set of 2023. Now I have passed in the graduation year and I've assigned it to self graduation year. I run it in the console and I should have no errors when I run it in the console. I have my John Doe still as such. Now I want to print to the console the username, the first name and the last name, then the graduation year. So I want to use another method to do that. So I can simply come into my child class and define another method called, let's call it welcome. We'll say welcome and we're passing the self because I want to reference all instances of this class. Then I want to use all instances to welcome the user based on the information he has given me. So I would say welcome welcome. Then let's start with the self dot first name. Self dot first name. Self dot first name. Okay. Then we add his last name. Self dot last name. Then we're welcoming him to the set of 2023, or to the class rather, to the class of, okay, 2023. So we need the graduation year for that. Self, let's drop this to a new line. Self, that's graduation year, and we're done. Done with the welcome function or method, as the case may be. I'm having an indentation error. I'm going to fix that now. Just a space here. Python relies heavily on indentation, so always make sure your definitions are on the same indentation block as they ought to be. And we are done. Okay, so now I want to use the welcome function here, like I did before. Clear this up in the console. Then when I run it, I should see welcome John Doe to the class of 2023. So let me go over this from the top again. We created a class of person, which happens to be our parent class. And we now passed in that parent class to this student class here, making this student class a child of the parent class person. I also added more attributes and properties and methods to this child class, and I did not want to lose the inheritance I got from the parent class. That was why I implemented this super function to still reference the parent class in the child class. And I have defined another function here, which is the welcome function, to welcome the user based on the information he has passed. And the only information that he's adding, which is different from the person, is that he's adding the graduation year. So I am going to create a new object on line 18, which I'm going to pass in the student's class, gave it a name, gave it a last name and the graduation year. Then I simply came here to call on the x.welcome. I can also still call on the x.print name to show you that we can access methods from the parent class as well. I still have John Doe for the print name on the parent class, and I still have my welcome on the method for the child class. This is the concept of inheritance in Python. You can interchangeably inherit from different classes and use them in a child class and pass in more attributes and method in that child class and work with it as such. This is a very powerful feature in Python, inheritance. You can do a whole lot with inheritance. You can imagine a scenario where you have a person, and from that person you want to create other children, sorry, from the person class. You could have a student, you could have a lawyer, you could have a soldier, you could have plenty of professions that are all people, but you want to give them certain attributes that will differentiate them from other children. So this is how you could go about it with the concept of inheritance in Python. The next, we're going to be looking at polymorphism, another concept of OOP. See you guys there.